To calculate the pressure of all species at equilibrium, we will need to set up an ice chart for the decomposition of PCl5 into PCl3 and Cl2. And let's also write the expression for Kp, which is very similar to the expression for Kc, but rather than concentration, we'll use partial pressures. So Kp is the partial pressure of PCl3 times the partial pressure of Cl2 over the partial pressure of PCl5. Since we want to calculate the equilibrium pressure, we're going to need pressures in our ice chart. Now, we are not given the initial pressure of PCl5, but we can calculate it using the relationship between pressure and concentration in the ideal gas law. So we know that the pressure is what we're going to be solving for, and the volume is given in the problem. The reaction is done in a 12.80 liter vessel. The moles we need to calculate, however, we have the 11.65 grams of PCl5, and so we can find the molecular weight of PCl5 from the periodic table to calculate the moles. And that is 208.24 grams. So the moles of PCl5 is 0.0559. The constant in the ideal gas law is 0.08206 liters times atmospheres over mole Kelvin. And the temperature, we're given 250 degrees Celsius, but we need Kelvin, so let's add 273, which gives 523 Kelvin. We can plug into the ideal gas law. P times 12.80 equals 0.0559 times 0.08206 times 523, and find that P is equal to 0.187 atmospheres. This is the initial pressure of PCl5, which we can now use to set up our ice chart. So we've got our 0.187 atmospheres, and we haven't created any PCl3 or Cl2. Only one way the reaction can proceed, and that is forward. So minus x plus x plus x. And at equilibrium, we add the I and the C. To solve for x, let's plug into our Kp equation. We know that Kp is 2.15, that's given. And we'll end up with x times x over 0.187 minus x. Let's move the denominator to the left side of the equation and distribute to get 0.402 minus 2.15x, which equals x squared. We have a quadratic equation, so let's move everything to one side of the equation to get the general form of a quadratic. You can solve for x by using the quadratic formula or plugging in the values of a, b, and c into a quadratic solver. And we will get x equals negative 2.32 and x equals 0.173. Since we can't have negative pressure, we can eliminate x1 and use x2 to plug in to the equilibrium pressures in our ice chart. The partial pressure of PCl5 is 0.187 atm minus our value of x, which equals 0.0140 atmospheres. And the partial pressure of PCl3 is equal to the partial pressure of Cl2, which is equal to the value of x, 0.173 atmospheres.